Good evening, everybody. This is Slooh. I'm Bob Berman with a special program today on the near close encounter with the asteroid 2000 EM26. And as it whizzes past our planet tonight, we're also going to be reviewing the extraordinary events of 1 year ago when Earth got actually struck, or at least our atmosphere did, by one major meteor, the largest in a century, in Siberia, while another, one of the largest asteroids in our lifetime, came closer to us than our geostationary satellites. Joining us will be Paul Cox, our technical director, coming to us from the Canary Islands, where the Slooh's main facility is located, and also special guest, Dr. Mark Boslow, who is an expert at planetary impacts and global catastrophes. Dr. Boslow works at the Sandia National Laboratories, and it's we couldn't do better in having a person who will really tell us what the honest to goodness threat is we're also going to look at some extraordinary images that have been collected from that event a year ago. And I want to first tell you that at the Canary Islands facility, we have snow, so much snow and ice there that we are unable to open that observatory. In fact, the military have come up and offered to evacuate the people at the observatories at the sites there. Paul, you're standing by there, aren't you?
That's right. Yes, Bob. We are basically marooned here. We're up at 8,000 feet at the Slooh Canary Islands Observatory. It's on top of a volcano, basically, and we've had ice and snowstorms. I mean, it's just part of the global, really unusual global weather that everybody's having. But, yep, the domes are iced up, but we have got some images coming in from our partners over in the Dubai Astronomy Group, Bob. So we will have some images a little bit later.
Excellent. So we are waiting for this. Now, this asteroid 2000 EM26 is an asteroid that may be as large as 3 football fields. We're talking about 300 yards across. Perhaps it's only 200 yards across. We're unsure. It was first discovered almost 14 years ago. It's whizzing past us at 17,000 miles per hour at a distance of a little closer than 9 times the distance to the moon. So no need to worry. This is no chance that it's going to impact us. We're talking about a little over 2 million miles. What's interesting is that it's happening almost on the exact anniversary of these extraordinary events of 2 years ago. But just as interesting, when it was discovered, it was classified as a potentially hazardous asteroid. And yet, as it circles the sun, when it was looked for again in 2006 and 2009, it could not be found. So this particular asteroid has not been recovered, has not been seen since 2000. So what we're attempting to do tonight is point our telescopes to where we expect it to be. And if we see it, well, that's going to be historic because we've reacquired a potentially hazardous asteroid. If it turns out we can't see it there, we're going to be asking, well, where the heck is it? And losing track of a potentially hazardous asteroid will, again, highlight the fact that there's a lot of stuff going out there that can do us harm. We don't want to overemphasize the dangers, but we certainly don't want to minimize them either. And so this is the perfect time to bring on Dr. Mark Boslow. Welcome to the show, Mark. Glad to have you.
Thank you. Good evening.
And what are your thoughts on this anniversary of the events of a year ago? What do you take from that?
Well, of course, it's been just over a year, and I've been thinking about it a lot. Of course, people have been asking me a lot of questions about what I was doing a year ago at this time, and I was getting ready to go to Russia. The events of February 15th were really amazing. I mean, it was one of those things that you don't expect to experience in your lifetime. And, you know, the most amazing thing about it is it happened over a populated area. And so there were all these dashboard cameras that observed this. And so it was really well documented, even though it was just serendipitous. It was an accident that it came in over a populated area.
Now, while you're speaking, Mark, we are showing our viewers the video, a colorful video of the airbursting asteroid over a series of buildings. And so can you comment on that?
Okay, I can't actually see that on my screen, but it may be one that's shown from the north. It's going from left to right.
Correct. Yes.
It
yes.
shows that it's coming in at a grazing angle. You can tell that from the video that it didn't come in at a very sharp angle, and that turns out to be very lucky. It turns out to be lucky from a scientific perspective because it took a long time to traverse the sky, and so we got a lot of data. And it also turned out to be lucky from a sort of a hazards perspective because it traversed so much atmosphere that it used up all of its energy before it got deep into the atmosphere and close to the surface. So all that energy stayed away from the Earth's surface, and so the damage was not as severe.
Yes, we're seeing a cloud of material that's expanding so rapidly in this colorful video that even the smoke from the chimneys in the foreground are barely moving by comparison. It just shows how rapidly it must be supersonic,
Oh,
certainly.
okay, now I see what you've got up on the screen, and that's actually a simulation. That's our computer model of the event. So this is not one of those dash cam videos. This is the what you see is a cloud. The growing cloud
Yes.
is from the energy that was deposited in the atmosphere, and we use the data from the actual event to initialize this simulation. So this is a 3D computational simulation using a hydrodynamics code that was developed for nuclear weapons simulations.
Excellent. And I believe at Sandia, nuclear weapons is something you do there, isn't it?
That's our primary business.
So, and I believe we'll now show a simulation or a calculation on a graph showing what would have happened at the atmosphere and why this burst meteor did the damage it did. Yes, I don't know if you can see that now.
I can see I've got a lag from what I'm watching, but if it's kind of at a deep angle, I'm kind of showing the difference of what happened if it had come in at 19 degrees from the vertical rather than 18 or 19 degrees from horizontal.
So we got lucky. How did it compare to the last? How does it compare to last time that are at pulled by an object of near size?
Well, one in 1988, the Tunguska event, it was probably about 10 times bigger in terms of mass. That's roughly twice the diameter. It was about, well, I think about 40 meters in diameter, or 20 feet or so in diameter. So an order of magnitude more energy, and it's also came at a deeper angle. It came, I think, about 35 degrees, twice the angle, and because it had so much mass, momentum, and more energy, there was a lot more to the surface. So that knocked over these, or an area of over 1,000 kilometers, almost 1,000 miles.
Now, an excellent planetary impacts of global catastrophes. It's my understanding that you have concluded, after studying this your entire life, that the chances of an object of this size doing us harm is actually greater than we used to think. Is that true?
Well, I'd like to clarify that. So I think the assessed risk, the actual risk hasn't changed. It's really our assessment of the risk that's changing as our understanding develops. And our assessed risk of the small ones, the air bursting ones like Chelyabinsk and Tunguska, that is increasing. We think they happen more often than we used to think, and two, they're more dangerous. More of the energy gets to the ground for a given amount of energy than we used to think. So our estimate of the risk from those is greater, but our assessment of the risk from the really big ones, the one that's flying by tonight, and bigger ones, our assessment of the risk from those is going down. And the main reason is that we're discovering them, and the ones that we're discovering are not on collision courses. The ones that we're discovering and we can keep track of, that is.
Fascinating. And obviously, this has grabbed NASA's attention because just this past September, NASA held a what they called an Asteroid Grand Challenge workshop, and our technical director, Paul Cox, was there for Slooh. Paul, is that true that NASA wants the public to be more aware of this danger?
Absolutely, Bob. And, they told us when we were there that, the reason why they invited us was a couple of years ago, this kind of came to, a peak at Slooh. And we started seeing these near-Earth asteroids discovered within a couple of days of them making their closest approaches to Earth. And basically we started a campaign and we started showing these objects live. We've got a whole bundle here, just some of them discovered a couple of days before they were making their close approach to Earth, well inside the orbit of the moon. And NASA invited us there to make a presentation to the Asteroid Grand Challenge workshop. And we are now partnering with NASA to really expand an observing campaign. So we are trying to enlist a legion of amateur astronomers, citizen scientists to help using the Slooh telescopes to help track and characterize these near-Earth objects. So
excellent, and we're seeing that right now. I don't know if you can see what we are showing the public, but these are actual images that you were responsible for using the Slooh equipment of tracking, and it's very difficult to track a very close asteroid as it moves quickly across the sky. But we're looking at near-Earth object 2012 DA14 as it's speeding against the background stars right now.
Yeah. And what we've already got, Bob, is a number of Slooh members, part of what we call the Slooh Research Group. And they are already involved night after night in tracking these objects. So predominantly newly discovered objects, which we don't fully understand their orbits. We don't have their orbits determined very accurately. So the Slooh members, they're using the Slooh telescopes. They take these images, and you can see how difficult it is, even when you know where one of these things is, how difficult it is to actually spot them in one of these images. Well, they perform what's called astrometry on these images, and they make submissions to the Minor Planet Center, and that helps accurately determine the orbit of these newly discovered near-Earth asteroids, so they don't follow in EM26's way of being observed, being discovered, but then lost for a decade.
It will be fascinating to see if tonight we can reacquire this asteroid that's passing, and we might as well tell everybody it just passed in the past hour, just 8.8 moon distances from Earth. Now, that may seem pretty far away, almost 9 times the distance to the moon, but that's still a good 15 times closer than the nearest planet. And so we need to keep track of these objects. If you're just joining us, this is Paul Cox, technical director. I'm Bob Berman, Slooh astronomer and author of The Sun's Heartbeat. And we have our guest, Dr. Mark Boslow, who is an expert on planetary impacts and global catastrophes. Mark works with Sandia National Laboratories. He has just told us that the assessed threat has been changing and upping the threat for us getting hit by an object of the size that burst over Siberia a year ago, although the threat of an extinction level event, such as the one at the KT boundary 65 million years ago that got rid of the dinosaurs and paved the way for the ascendancy of us mammals and rats and sitcoms and all the things we have today, that was made possible by that incoming object. That threat is actually reduced. Now, we're going to show an image now from some webcams from the event from a year ago, and I would love for Mark Boslow to comment. Now, we're going to use some webcams in Russia to see this incoming object that happened on February 15th, 2013. And we're seeing it now moving across the sky from left to right. And what do you take away from this, Mark?
Okay, so if you're showing the one I think you are, it's coming in from the left and it starts to glow and it gets really bright, and then you see it explodes and then it leaves a trail.
Exactly.
And so what I and others were able to do was to calibrate these YouTube videos, these dash cam videos, and determine its trajectory precisely. And then what my colleague Peter Brown and his group did was they were able to extract the brightness as a function of time and position along that trail, and from that we could infer the amount of energy that was deposited in a parcel of atmosphere along the trajectory, and then I could use that to initialize my simulations, what you were showing earlier.
And the amount of energy, as we again see just these fantastic images of it coming in, was greater than a nuclear bomb explosion, was it not?
That's right. It was about, our estimate has significant uncertainty, but our best estimate is about a half megaton.
Half a megaton, which of course
Half a
is
megaton. And that comes from multiple independent sources of information, from infrasound, the very low frequency sound waves that you can't hear that traverse the entire planet, and from the period of that infrasound wave, that period correlates with the yield of the explosion. And that was one way of estimating it. That was one of the early estimates. And all the estimates seem to be consistent.
My goodness, that's more than 20 times the explosion of the Hiroshima bomb over Japan. This was quite a burst, and it was something like 18 miles up, was it not?
That's right. Yes. I mean, it traversed a lot of sky, and it was descending while it was, but the main explosion was between 18 and 20 miles up.
All right, what we're going to show now are some of the other videos from that event from a year ago, and both from
some
webcams.
And I don't know if you're playing the sound, but some of them are quite spectacular in the booms, the ones that are directly beneath.
And it must have taken some time for the sonic boom to arrive. As I understand, there were 1,500 injuries from broken glass, flying glass.
That's right. And of course, what happened was, the bright flash in the sky and the strange cloud drew people to the windows. It was early morning. People were already at work, and they started, looking at the sky through the windows. And it took 2 or 3 minutes for the blast wave to get there, and it was so strong that it blew out the windows. And most of the people who were injured by flying glass.
We're now showing some pictures from, it looks like in a warehouse, of the blast blowing down a door right on top of some unfortunate people who were just exiting that door at the time. And
and you can see, where there's a structure, the pressure builds up. There's a dynamic pressure, but then that blast wave reflects off the surface, and so the pressure builds up, and there's more pressure outside than inside. And so the building, whatever the weakest part of the building is, whether it's a window or a big garage door in a warehouse, it blows in, and it blows in with a lot of force.
Now, you started your interest in this, I understand, even in childhood, when you observed the Perseid meteors, the great August 11th shower that many of us love to see. But back then, you didn't just merely count meteors. Tell us what really started you on this. What did you do during these meteor showers?
Well, as a kid, we were Boy Scouts, and we used to camp out in our backyards, and we'd do this every August, and we'd just, get out of our tents and lay in the backyard and watch the sky. I grew up in Colorado, where it was usually clear in the summer, and it was just very mesmerizing and magical to see these, flaming dust particles traverse the sky. And then in 1972, our family happened to be taking a vacation in the Tetons, and there was this great fireball of 1972, which we didn't see. We were there, but we didn't see it. But we talked to people who did, and much later, I learned that it had been recorded on one of those old Super 8 film movie cameras, and had gotten shown on TV. You can find that on YouTube now.
And then you did experiments with objects flying into mud or impact?
Yeah, then I majored in physics, and I went off to Caltech to do my PhD research and started making craters using hypervelocity launchers and very high-speed guns to fire projectiles into targets, and looking at the effect that the high-velocity collision had on the targets, looking at the temperatures of minerals and making craters and looking at the properties of the craters that formed. And then I got a job at Sandia, and I got to keep doing similar things.
It's hard to believe you actually got paid to do what probably every boy in the world would have loved to do.
I got paid to shoot big guns and to blow things up. Now I do it all on computer. I've jumped from experimental to computational physics, which lets me do things that I can't do in the laboratory, like, set off half megaton explosions.
Hmm. We're going to now show an image taken apparently in the west of a fireball going across the sky. And this is one that you've supplied, showing, in this case, it's a fireball, it looks like going from right to left and either impacting or blowing up in the air in a desert-like setting.
I think I know which one you're talking about, and that's the one, that's also a simulation, and it's a simulation of that I did back in the 90s, showing what a Tunguska-like impact would be like if it happened in New Mexico, and you're looking at the Sandia Mountains. You're actually looking down my driveway.
It looks like you have dark skies there.
Yeah, I can see it now. And so what I was illustrating with this was a plume. So when you have a steep impact, you get this giant plume of vaporized asteroid mixed with hot air that expands into space above the point of impact. We didn't see that for Chelyabinsk, and it's because it came in at such a shallow angle. The plume formation apparently requires a steeper angle.
I see. I see.
Bob, excuse me. May I
Yes,
just interrupt for a second?
Please.
Just to let you know that we have got some images now coming in from Dubai. They are transferring over to the USA for our producer. He's going to be showing those very shortly. Now, what viewers have got to keep an eye open for, it's a series of images. And what we're looking for is one of the small dots to be moving from one image to another. Now, don't forget, this thing hasn't been observed for 14 years. To all intents and purposes, it's lost. So if we actually spot that moving object in one of those images, we have reacquired or rediscovered this particular asteroid, this potentially hazardous asteroid. So those images are coming up, folks. Sorry, it's taking a bit of time to get them from Dubai and fed through to us, but they are on their way very shortly.
Excellent, excellent. What we're talking about is tonight's, I don't know if we can quite call it a near miss, because the asteroid 2000 EM26 is passing a little bit closer than 9 times the distance to the moon. So those who think that, I know we always have some people who think the government has been covering something up and we're really in imminent peril of being clobbered. No chance of being clobbered tonight. However, this is an object that may be as large as 3 football fields. It's a substantial asteroid, passing us at a rate of 17,000 miles an hour. It's not an easy object. It's at magnitude 16.1. That's the projected magnitude. It means it's fainter than Pluto, and acquiring it is not easy, but that is what we are attempting to do. And considering that this is close to the exact anniversary of the amazing events of a year ago, it's very exciting. And in case you forgot what happened a year ago, we have Dr. Mark Boslow, who has been reminding us that on the very day that we had 1,500 injuries over the city in Siberia, Chelyabinsk, because of an air bursting incoming asteroid that had not been discovered ahead of time. It came at us, nobody knew it was coming, and on that very same day, by extraordinary coincidence, we had the probably the largest asteroid that came closest to us in our lifetimes, the asteroid DA14, 2012 DA14, that actually passed nearer to us than our geostationary satellites. And that one, we can show you that one in a moment. Here it is. As Slooh tracked it, this is the Slooh Community Observatory. Our members are watching the skies every night, taking turns using the automated observatories on the Canary Islands. Tonight, the Canary Islands facility is iced over, snowed over. In fact, there were offers of being evacuated from the Spanish government that runs it, from the military. But here it is, Slooh tracking it a year ago. This was the same day that the famous asteroid burst in. And then just to make that coincidence even more astonishing, a century earlier, on June 30th, 1908, the last time a air-bursting asteroid did damage in the world, knocking trees down for 50 miles in all directions, was also over Siberia. Although we did have perhaps a more dramatic event, and if I mention the name Ann Hodges, I'm sure that'll mean something to our guest, Dr. Mark Boslow. Ann Hodges of Silicoga, Alabama, in 1954, was the one authenticated human who was actually struck directly by a meteorite. You might wonder how these names change. What's the difference between an asteroid, a comet, a meteor, a meteorite, a meteoroid? Well, the moment it makes contact with the Earth, if you can pick it up, if it hits you, it becomes a meteorite. If it's a streak through the sky, it's a meteor. If it's an invisible object flying through space, of course, it's not glowing, and you're not likely to see it at all. That's a meteoroid. And that could be made of a fragment from a comet or a fragment from an asteroid. It's sort of a generic term to say meteoroid. But Ann Hodges, she was actually struck and thus became a drama that almost had no equal, as she battled for custody of this stone that actually had injured her, and the landlady really wanted it, and it went to court, and it made all the papers. And meanwhile, nobody made out well with that one, except for a man who happened to see a companion rock. Sometimes these break apart in the air, and another piece of the same incoming meteor in 1954 landed on a road, and a man saw it while driving his horse cart, pushed it aside. Then later, when he heard about the meteor that came through the roof of Ann Hodges' house and struck her and injured her near her hip, he went back, found it, got an attorney, and ended up selling it to the Smithsonian for enough money so that he could buy a new house and a car. And it wasn't easy being a black man back in Alabama in the 1950s to have a happy ending like that. So I'm happy to report that there was an incoming tale that brought at least some good luck, some good fortune.
Excuse me, Bob. May I interrupt again?
Please.
We do have the images coming in now from Dubai. So these are monochrome images. They're grayscale images. So what we can see in them is a background field of stars. Now, based on the observations in 2000, when this was first discovered, this is where the object should be. This is where this asteroid should be. And the way that we can track these faint asteroids, unless they're bright enough to see moving between, or very obviously moving between each image, we have to look incredibly carefully at a whole sequence of images, as we've seen in some of those time lapses that we've produced before, to see whether or not there's a moving image. Now, if there's a moving object. Now, with these particular images, we are going to have to look really, really hard for this thing. It could be right out on the edge of the field. It might not be there at all. Don't forget, it's last observed in 2000. So our producer is going to be showing you this series of images that have come straight from our partners at the Dubai Astronomy Group. They're very kind to get this feed set up for us tonight, and keep looking at those images and try and spot the object that moves. We will do some more analysis of this later on as well, of all of these images. So Bob, back to you while we look at these images from Dubai.
Okay. And it should be mentioned that it's not just this and the objects for a year ago. We were here on the Slooh Community Observatory tracking the asteroid Apophis on January 9th of last year. Apophis is very, very famous, and I could talk about it, of course, and the fame that it has for its visit in the late 2020s and then its return. There's a lot of scare stories about that. But what do you think of that one, Mark? Apophis. That doesn't worry you, does it?
No, it doesn't. And the probability, I mean, there's always uncertainty associated with orbits. And that's why there's uncertainty as to whether something is going to hit the Earth or not. And as more and more observations take place, it gets tracked better and better. For example, the one tonight, if it's reacquired, then its orbit will be known much more precisely. And the next time it comes around, it'll be much easier to acquire. So likewise, as we got more and more data on Apophis, it became more and more clear that it wasn't going to be on a collision course. So I'm not worried about that one at all. I mean, there's still a very tiny probability, tiny likelihood that it'll hit the Earth sometime in the distant future, but it's very unlikely.
So we're not worried about the 2029 encounter because that should again pass us by the distance to our Earth satellites. But wasn't
Right.
there some small chance, 1.25 million or something, that the next time around, 6 years later, its orbit could change because of its gravitational encounter with Earth, and perhaps one chance in 250,000? Of course, we should all be worrying about cholesterol more than Apophis, shouldn't we?
Right. If you kind of look at the relative risk of something like that, it's not really worth worrying about, and we will get a better look at it. And we expect that to go to zero. I mean, there's a very, very tiny chance that it won't. But yeah, when it comes around in 2029, it will be perturbed by the Earth, and that perturbation is very strong and very highly dependent on precisely the distance that it passes the Earth. So its its perturbation, its new orbit after it passes the Earth will be a lot different. And so there's a very tiny chance that new orbit will be one that intersects the Earth.
Now, Mark, do you know of any other named asteroid that has a better chance of hitting us in our lifetimes than Apophis?
I think there are. I would have to go to the JPL NEO website to look. There aren't any that are really high on the list, and I'm not somebody who keeps track of that very carefully. But if a question comes up, I go to that JPL website, and they have the whole list there. Rather than read you the name of the website, if you just Google the letters JPL, as in Jet Propulsion Lab, and NEO, as in Near Earth Object, it'll be the first hit, and you can click on that, and then you can surf around and look at everything there is to see.
Good, good. And one of the reasons I bring this up is that we always get inquiries, and we'll take some questions shortly from our listeners and viewers. But there are always people who think that the government is covering up an imminent collision threat, and that a catastrophe is right around the corner. And I think that's one of the reasons that our previous shows, when we've tracked near-Earth objects in the past couple of years, of course, 2012 DA-14 a year ago, and Tatus and Apophis, and now 2000 EM26, is that little bit of a scary thought that perhaps one of these objects has our name on it. And it should be mentioned, of course, that objects are hitting us. Dr. Boslow mentioned the Perseid meteor shower. We have major meteors every year on August 11th, and then again on the night of December 13th to 14th. These are 60 to 100 shooting stars per hour, and these are collisions with Earth. These are small pieces, most of them the size of apple seeds, very small, but a few of them a little larger than that. But it's not quite empty space, is it? Up there.
No, and we get hit by the little bitty things all the time, constantly. There's a constant rain of small objects hitting the Earth, and that's what you see as shooting stars. And as you go up in size, there are fewer and fewer and fewer. And when you get up to the big ones, the ones greater than a kilometer, 0.6 miles, there's only about 1,000 of those. And most of those now have been discovered. Something like 95% of those are now being tracked.
Yes. I think most people are surprised at how many, however, do come in and do damage. I believe a home in North America is hit once every 2 to 3 years on average. We know in Wethersfield, Connecticut, we had in that same town, we had homes damaged by meteors in 1982 and 1971. I know I spoke to Bob and Wanda Donahue in Wethersfield after that event in November of '82. They said they heard the loudest sound they'd ever experienced coming from the next room. They'd been watching TV, MASH. I asked them what were seeing MASH on TV, and they rushed to the next room, and there was a hole in the ceiling, and the furniture had been knocked over, and they called the police, and it was firemen who came with the police that discovered it, a meteor that was almost 10 pounds in size. And I asked them if their insurance covered it. What do you think, Mark? Did their insurance cover them for the damage?
I don't know. I don't know
It did. It did. They said
policies
their
have,
policy
they
covered
don't
it.
have a meteorite clause. That insurance company probably has a meteorite clause now. Did they get to
and
keep it though? That's the question. Did they get to keep it?
they got to keep it, and then they generously donated it to a museum in New Haven. But what was amazing, of course, is that previous time that a home in America had been damaged was in that same town of Wethersfield, and the only explanation we have, of course, is that Wethersfield is a suburb of Hartford, where all the insurance companies are. You know, that's where the actuaries live. They know this thing can happen. You know, the town being hit twice in a row. So, we do get houses that are struck. We had a couple of boys in Noblesville, in Indiana, 20 years ago, and one was just speaking to another, was sitting on his bike, not riding it, but just standing there astride the bike, talking to his teenage friend, when one went thump into the lawn, right in front of these boys. And for those who think that an incoming bit of asteroid material is hot, or a meteor is hot when they touch it, they were able to pick up this meteorite, and they reported that it was barely warm to the touch.
Was this the
And
one in Monahans, Texas?
no, this was in Noblesville, Indiana.
Oh,
And
okay.
I know the calculation is that objects of this size, we're talking about 6 pounds, 8 pounds, 10 pounds, are slowed by the atmosphere, so that their typical impact speed on a roof is something in the order of 250 miles an hour, which lets them typically penetrate a roof, often one additional floor, and then come to rest. Whereas if an object is, and correct me if I'm wrong, but the figure that I've read is something like 80,000 tons, which fortunately is rare in the extreme. But if a object comes in at more than that, it will not be slowed down by the atmosphere, and it will hit at full cosmic velocity. And since kinetic energy is, of course, equal to mass times velocity squared, the velocity is very important in such cases, and that's why a very large object is doubly dangerous, because not only is it heavier, but it's not slowed down by the atmosphere as much, or even at all. And so it can come in at crazy speeds, 18 miles a second, 20 miles a second, 30 miles a second. And then you don't just have a hole in the roof and a little bit of damage in your house. You have a crater, or worse than that. We're looking now at Slooh's coverage of Tutatis that we tracked. Paul Cox, our technical director, was responsible for getting the Slooh telescopes to do something that they weren't really designed to do, and that is track these fast-moving objects. We see the stars, there's streaks behind them. And I'm welcoming everybody who may be just joining us for our coverage of tonight's near-Earth encounter of the asteroid 2000 EM26. We're trying to reacquire it. It's been lost. That's a little creepy, a little scary, that an object that has been officially characterized as potentially hazardous has not been seen in its further orbits around the sun. Now, it has an orbit of 269 days, so it comes around the sun in less than a year, and yet nobody can find it. So we're looking for it tonight, and NASA and the world is becoming more and more aware that it might be a good idea to track near-Earth objects, hazardous potential impactors, and maybe have a chance to see them coming. What do you think of the idea, Mark, of perhaps even spending the resources to develop a way to deflect potentially impacting objects, or do you think that's too low probability and too sci-fi?
Well, no, I don't think it's too low probability to think about and even to study it. But when you think about where our resources should go, it makes more sense to me to put most of our resources into telescopes. As my colleague Don Yeomans from JPL says, there's really three things to think about, or three rules for planetary defense, and that's find them early, and find them early. If you don't find them at all, you can't do anything at all about them. If you don't find them soon enough, you still can't do anything about them. So you got to find them long before impact. Now, I'd put a caveat on that. I would say if they're small, if they're objects the size of Chelyabinsk, if that had been discovered a day or two in advance, well, then people could have been warned, and there could have been a take cover warning, so that people wouldn't have been hurt by standing next to windows, because they didn't know what it was. They were surprised, and they did what anybody probably naturally would do, and that's to go to the window. But if they had been warned, they probably wouldn't have, and it would have saved a lot of injuries.
Or open the window if you want to look at the sky, right?
I'd go outside, but we probably wouldn't know how big it was either. We wouldn't have time to really characterize it. And when you warn people, like the National Hurricane Center does, you kind of want to give them the worst case scenario, and that might be, don't go near a window and stay indoors, go down in the basement, something like that. I'm not sure what the warning would be, because I don't know what we would have known. If it was something that would be spectacular but harmless, except for maybe a big boom, then you probably want to tell people to watch it from outdoors so they don't get hit by glass, and just be in an open area where nothing's going to fall on them.
Okay, now to Paul Cox in the Canary Islands. Paul?
Yeah, Bob, I just really wanted to give a little bit of a recap for anybody who's been joining us late. I'm talking to you from Slooh's Canary Islands Observatory. We're iced up here, so we weren't able to bring you images of 2000 EM26, this near-Earth asteroid, this potentially hazardous asteroid from the Canary Islands. But we've had some images coming in from our partners from the Dubai Astronomy Group, and they've been feeding us these images. And we're going to have to look at these really closely. Now, don't forget, this asteroid was discovered in 2000. It had 32 observations over a period of 9 days made of it, and then nothing. It made close approaches in 2002, 2003, 6, 9, 11, and 12, but nobody managed to recover this object. They couldn't find it again. And we're not talking about a small asteroid here. We're talking about an asteroid which is between 400 and 800 feet in diameter. This is not a small lump of space rock. And it was classed as a potentially hazardous asteroid because of its size, because of its proximity to Earth and the passes it could make. So what we've been trying to do tonight is recover this extraordinary object that was discovered back in 2000. But what we also do here at Slooh is members virtually every single night track newly discovered asteroids. These appear on the Minot Planet Center website, and it's really they ask, look, this thing's been discovered. Come and help us determine its orbit, because we don't know it accurately. And unless we get more observations of it, like you're seeing now, these are all from the Slooh telescopes. These are from our members in the Slooh research group. And they perform measurements of it. They submit this information up to the Minor Planet Center, and that is what enables us to keep track of these dangerous objects. And what you're seeing here, a lot of these images, you'll see the name of them. Asteroids, they're named by the year they're discovered, the month and the week that they're discovered. So anything you're seeing here, this one here, 2014 BH3, this was only discovered a couple of weeks ago. But Slooh members immediately start trying to track this thing so it's not lost, like the asteroid that we've been tracking tonight. So, Bob, back over to you. I hope that's kind of brought anybody up to speed who's joined us a little bit late.
Yes. And as long as you're mentioning the Slooh Community Observatory, just for people who think that, well, is that what we do, everybody does, is track asteroids. A lot of people use the giant telescopes to look at galaxies and beautiful nebulae. And I wonder if our producer, Michael, has, just any image that any member has taken in the last few weeks of
Actually,
the
Bob,
Orion Nebula or anything like that, just to give you a sample of what the telescopes look at.
While those are coming up, I mean, a lot of the shows that we do on these near-Earth asteroids that are making their closest approach only within days sometimes of being discovered, it makes the kind of images look a bit boring. We're looking at small white dots against other small white dots. But actually, the vast majority of Slooh members are imaging are creating images like this. And Slooh has this. I'm not doing a sell, I'm just trying to explain what we're about to see. That is processed in real time. There's the Orion Nebula. So you don't have to know anything about how to use the telescope. It's really easy to use and go. I'm not going to oversell it because that's not what we're here for. But we did just want to point out that actually you can use these Slooh telescopes for a lot more than just these faint fuzzy objects, however important that work is.
Yes, and this is a very recent image of the Orion Nebula, birthplace, the nearest birthplace to Earth, of new baby blue stars. They're just popping into existence like robin's eggs in the middle of this giant, womb, cosmic nursery, about 30 light years across. So,
but now, Bob, we're gonna just flick back to some of the last images coming in from the Dubai Astronomy Group here. So these are the images that they've been taking over recent minutes of the star field of where this near-Earth asteroid, this potentially hazardous asteroid, that's what it's classed as, discovered in 2000 and not observed since then. It's somewhere. It should be in that field. So we're going to have to look really, really closely at these images a little bit later to try and see if we can spot that moving dot against all of the other moving dots.
That's right, and not too much of a moving dot. It's about 6 times fainter than the planet Pluto, or the poor demoted, I should say, explanet Pluto is. So this is, it's not a very bright object. We're talking about something that may be as large as 3 football fields, 9 times farther from us than the moon. Far cry from those events of a year ago when we had 2 objects come in very close to Earth, one visibly moving across the sky. The Slooh telescope was barely able to track it. It was moving so frantically closer to us than our own Earth satellites, or at least our geostationary ones. And then a second object the same day bursting 18 miles over the city of Chelyabinsk in Russia and injuring 1,500 people. So that we went in a single day a year ago, and we're commemorating that tonight with this passage of this new asteroid. We went from a single person having been injured, Ann Hodges, back in 1954, struck in the upper leg by a meteorite, to 1,500 people being injured by one. And it just shows that, well, you never know, do you? Before we close the show, I want to go back to Dr. Mark Boslow. Any last thoughts about these hazards, and what is your next project? What do you intend to do with studying these planetary impacts and the potential for global catastrophes? What's next on your to-do list, Dr. Boslow?
Well, I'll tell you what I would love to do, and that's to collaborate with you guys. Because what I'm really interested in are these objects, not that are discovered way in advance, but the ones that are discovered on final approach.
Yeah, and that's our key target, which is we normally do, Mark. So.
Yeah, and some of those, it's happened twice in the last 5 or 6 years that an object has been discovered within a day of impact, and the impact was predicted. And, if that could be done more often and with more notice, we could actually get our own instruments to the site of the entry into the atmosphere. Now, these, for most of the time, would be small, harmless objects, but much bigger than the ones that we just witnessed by happenstance. And if we could set up spectrometers and infrared cameras and high-resolution video, and we could just set up the whole works, seismometers. We could really characterize this thing. So I would love to talk to you guys about that. In fact, in some places, it could be an opportunity for tourism, and we could track the meteorites all the way down to the ground and find them immediately.
Very exciting. Paul, any last thoughts from you?
Yeah, in 2 nights' time, we are going to be watching one of those very asteroids, one of these ones that was discovered only a couple of weeks ago, which is making a pass within 1 million miles of Earth. So we're going to be watching that live. Slooh members, we're going to be pointing those telescopes to it. Yeah, that's what we're going to be doing at Slooh.
Excellent. Well, I want to thank Paul Cox at Standing by the Canary Islands, our guest, Dr. Mark Boslow, and we hope to have you on again, Mark, when we get another close encounter past Earth. Your expertise on planetary impacts and global catastrophes is just invaluable. Your knowledge is just really awesome. Hate to use that word, it's an overused word, but in this case, I think we can do it. I'm Bob Berman, and I want to thank our producer Michael Wilson. Our executive producers are standing by, and that's Mike and Pat Palucci. So this is an intercontinental enterprise tonight, as we have brought you coverage of the near-Earth passage of the asteroid 2000 EM26 and reminisced, if that's the right word, of the extraordinary events that took place a year ago on February 15th, 2013, when we had two very, very close encounters indeed. Slooh will be continuing to monitor the sky, and the next time either predicted or unpredicted, when we get a close encounter, hopefully not of the clobbering kind, but a close encounter, we'll be back and we'll bring you more coverage then, as well as, of course, other celestial events as they happen. So thanks for joining us. For the entire Slooh team, I'm Bob Berman. Good night. Catastrophes. Dr. Boslow works at the Sandia National Laboratories, and we couldn't do better in having a person who will really tell us what the honest to goodness threat is. We're also going to look at some extraordinary images that have been collected from that event a year ago. And I want to first tell you that at the Canary Islands facility, we have snow, so much snow and ice there that we are unable to open that observatory. In fact, the military have come up and offered to evacuate the people at the observatories at the sites there. Paul, you're standing by there, aren't you?
That's right. Yes, Bob. We are basically marooned here. We're up at 8,000 feet at the Slooh Canary Islands Observatory. It's on top of a volcano, basically, and we've had ice and snowstorms. I mean, it's just part of the global, really unusual global weather that everybody's having. But, yep, the domes are iced up, but we have got some images coming in from our partners over in the Dubai Astronomy Group, Bob. So we will have some images a little bit later.
Excellent. So we are waiting for this. Now, this asteroid 2000 EM26 is an asteroid that may be as large as 3 football fields. We're talking about 300 yards across. Perhaps it's only 200 yards across. We're unsure. It was first discovered almost 14 years ago. It's whizzing past us at 17,000 miles per hour at a distance of a little closer than 9 times the distance to the moon. So no need to worry. This is no chance that it's going to impact us. We're talking about a little over 2 million miles. What's interesting is that it's happening almost on the exact anniversary of these extraordinary events of 2 years ago. But just as interesting, when it was discovered, it was classified as a potentially hazardous asteroid. And yet, as it circles the sun, when it was looked for again in 2006 and 2009, it could not be found. So this particular asteroid has not been recovered. Good evening, everybody. This is Slooh. I'm Bob Berman with a special program today on the near close encounter with the asteroid 2000 EM26. And as it whizzes past our planet tonight, we're also going to be reviewing the extraordinary events of 1 year ago when Earth got actually struck, or at least our atmosphere did, by one major meteor, the largest in a century, in Siberia, while another, one of the largest asteroids in our lifetime, came closer to us than our geostationary satellites. Joining us will be Paul Cox, our technical director, coming to us from the Canary Islands, where the Slooh's main facility is located, and also special guest, Dr. Mark Boslow, who is an expert at planetary impacts and global catastrophes.
And that turns out to be very lucky. It turns out to be lucky from a scientific perspective because it took a long time to traverse the sky, and so we got a lot of data. And it also turned out to be lucky from a sort of a hazards perspective because it traversed so much atmosphere that it used up all of its energy before it got deep into the atmosphere and close to the surface. So all that energy stayed away from the Earth's surface, and so the damage was not as severe.
Yes, we're seeing a cloud of material that's expanding so rapidly in this colorful video that even the smoke from the chimneys in the foreground are barely moving by comparison. It just shows how rapidly, it must be supersonic, certainly.
Okay, now I see what you've got up on the screen, and that's actually a simulation. That's our computer model of the event. So this is not one of those dash cam videos. This is what you see is a cloud. The growing cloud is from the energy that was deposited in the atmosphere, and we use the data from the actual event to initialize this simulation. So this is a 3D computational simulation using a hydrodynamics code that was developed for nuclear weapons simulations.
Excellent. And I believe at Sandia, nuclear weapons is something you do there, isn't it?
That's our primary business.
So, and I believe we'll now show a simulation or a calculation on a graph showing what would have happened at the atmosphere and why this bursting meteor did the damage it did. Yes, I don't know if you can see that now.
I can see it. I've got a lag from what I'm watching, but if it's kind of at a steep angle, I'm kind of showing the difference of what happened if it had come in at 19 degrees from the vertical rather than 18 or 19 degrees from horizontal.
So we got lucky. How did the to the last cover? It has not been seen since 2000. So what we're attempting to do tonight is point our telescopes to where we expect it to be. And if we see it, well, that's going to be historic because we've reacquired a potentially hazardous asteroid. If it turns out we can't see it there, we're going to be asking, well, where the heck is it? And losing track of a potentially hazardous asteroid will, again, highlight the fact that there's a lot of stuff going out there that can do us harm. We don't want to overemphasize the dangers, but we certainly don't want to minimize them either. And so this is the perfect time to bring on Dr. Mark Boslow. Welcome to the show, Mark. Glad to have you.
Thank you. Good evening.
And what are your thoughts on this anniversary of the events of a year ago? What do you take from that?
Well, of course, it's been just over a year, and I've been thinking about it a lot. Of course, people have been asking me a lot of questions about what I was doing a year ago at this time, and I was getting ready to go to Russia. The events of February 15th were really amazing. I mean, it was one of those things that you don't expect to experience in your lifetime. And, you know, the most amazing thing about it is it happened over a populated area. And so there were all these dashboard cameras that observed this. And so it was really well documented, even though it was just serendipitous. It was an accident that it came in over a populated area.
Now, while you're speaking, Mark, we are showing our viewers the video, a colorful video of the air-bursting asteroid over a series of buildings. And so can you comment on that?
Okay, I can't actually see that on my screen, but it may be one that's shown from the north. It's going from left to right.
Correct. Yes.
It
Yes.
shows that it's coming in at a grazing angle. You can tell that from the video that it didn't come in at a very sharp angle.